You've probably heard it a million times. You can't go faster than the speed of light. But have you ever stopped to wonder why? Is it just a technological hurdle, like we just haven't built a fast enough engine yet? Or is it something way, way deeper, something literally woven into the fabric of the universe? Well, let's get into it.
To really get to the bottom of this, we've got to reframe the whole question.
And yeah, this is the question we all ask, right? It totally sounds like a tech problem, just build a better rocket, a more powerful engine, and bam, we're off to the races, breaking that cosmic speed barrier. But here's the twist. This is where we stop talking about engineering and start talking about, well, the source code of reality itself. The problem isn't our gadgets, it's the universe's rules. It's not a wall we can just blow a hole through, it's a fundamental law of the game. Calling it the speed of light is actually kind of misleading. A much better way to think about it is the speed of causality. It's the absolute maximum speed for anything to happen, for a cause to have an effect. Light just gets all the credit because it happens to be massless and travels at this top speed.
Okay, so how does the universe actually enforce this? Like, what's stopping us? Well, it really boils down to two big reasons.
So, first up, there's a really practical physical problem. And this applies to anything with mass. You, me, a baseball, a spaceship, you name it. And it all comes down to one thing: energy. Think about it like this. As you accelerate something, you need to pump in energy. But it's not a one-to-one thing. The faster you go, the more energy you need for that next little nudge of speed. The closer you get to the light speed limit, that energy requirement just skyrockets. It goes vertical. To actually reach the speed of light, you'd literally need an infinite amount of energy. And well, that's just not going to happen.
Okay, but let's play a game. Let's say you're a wizard and you have an infinite energy cheat code. Now can you do it? Can you break the speed limit? The universe's answer is still a big fat no. Because there's an even deeper, more sacred law it's trying to protect. See, if you could go faster than light, you could literally break time. Einstein's relativity shows us that this would let you send a signal and get a reply before you even sent the original message. Think about that. The effect would happen before the cause. The entire logical flow of the universe, where A causes B, just shatters. It's a complete paradox.
So that's the real kicker. The speed of light isn't just about going fast. It's the universe's built-in firewall. It's a paradox prevention system, designed to protect the very concept of cause and effect.
So you've got the energy wall and the time paradox. Seems pretty airtight, right? Case closed. Well, not quite. Because then a guy named Richard Feynman came along and looked at this whole thing at the quantum level. And that's when reality gets just wonderfully weird.
All right, you're going to want to buckle up for this next part, because it requires us to accept a really strange fact about the quantum world. When a tiny particle goes from point A to point B, it doesn't just take the obvious straight line. In the mathematics of quantum mechanics, that particle takes every single possible path, all at the same time. I'm not kidding. That includes the direct route, sure, but it also includes a path that loops around Andromeda and comes back. And here's the mind-blowing part. It even includes paths that go backward in time and paths that are faster than light. The universe is literally calculating all the possibilities, even the illegal ones. So, hold on. If all this craziness is happening under the hood, why do we only see the normal, boring, rule-abiding stuff? This is the genius of Feynman's insight. Basically, all those impossible, crazy time-traveling paths, they all mathematically cancel each other out. It's like a bunch of waves that just perfectly destructively interfere, leaving behind only the sensible paths that obey the laws of physics. So get this. On some deep, fundamental level, reality is just this buzzing, chaotic storm of every possibility you can imagine, including time travel and faster-than-light shenanigans. But what we actually measure and experience is the calm after that storm. All the paradoxical stuff has washed itself out, and all that's left is the single, consistent reality we live in.
Okay, so we've been through the energy wall, the time paradox, and some truly mind-bending quantum stuff. What's the one single, simple rule that brings all of this together?
So, what's the universe actually defending with this rule? It's not really about speed, not in the way we think about it with cars or spaceships. It's about protecting the flow of the single most important currency in existence. And here it is, the real fundamental law of the universe. You cannot send new information faster than light. That's it. This is even why something as spooky as quantum entanglement doesn't break the rules. Sure, two particles can seem linked instantly across the galaxy, but you can't actually use that link to send a deliberate message, like hello in Morse code, faster than light. No new information can beat the clock.
Which brings us to the big final takeaway. This universal speed limit has absolutely zero to do with our technology. It's not about building a better engine. It's a baked-in feature of spacetime itself. It's woven into the very fabric of reality, just as fundamental as gravity.
So, I'll just leave you with this one last thought to chew on. Underneath it all, the universe's math seems to allow for all sorts of madness. Time travel, faster-than-light paths, you name it. But the world we actually live in, the physical reality we see, is always perfectly orderly. So, what does that tell you about the true nature of reality? It's something to think about. Thanks for tuning in.